And welcome to this instructional video of your Semester 2 Lab 3. This Lab 3, we are going to focus on two new experiments. So for Set 1 and Set 2, it's more like to get you familiarized with the format of Paper 3 and also to figure out how to measure oscillations. All right, so make sure you know how to measure oscillations and what are the best practices around measuring oscillation. Now we're going to jump straight in to Set 3, okay, where the first experiment has to do with circuits. So let us look at the instruments that is given to you. Okay, you will be given a low voltage power supply. So I think what I'll do is I'll bloop up the table camera so you can see how it looks like in real life. Okay, what you see now is a different kind of flat lay, not a bougie cafe place, but actually your lab setup. So first things first, we will have a power supply fixed at 1.5 volt, and this particular power supply would be the cell. All right, so if you look at this is a normal double D battery. It is 1.5 volt. You have to make sure that when you clamp it, these are the connectors. So every cell holder is different. Make sure you are familiar with the cell holder that you are given with. It may or may not be this one, it may be a different one. Okay, but don't worry, the telltale sign will be number 1. The connector will have metals. So you can see here, this is a place where we can clip. It's metal. This place is metal. Okay, if you are not sure that this cell holder works, you can always connect this directly to the power supply. Okay, to double check. How to connect? Go and watch the circuit best practice video. Always connect all your components to check and make sure that they are working. Okay, so I'm not going to do that in this video so that this video is not too long. I hope you've already watched that one. For all circuit experiment, check everything. Make sure it's working. Okay, so we have this. This is the circuit. This is your switch. Okay, again, when you examine the switch, please make sure you know this is the connection. Okay, so you'll probably be clamping your crocodile clamps here, and this will be the switch that you go up and come down, okay, to disconnect the circuit. So we have the switch. We have the ammeter. So this ammeter, right, it says range from 0 to 200 milliampere. So normally in the lab, again, you may or may not be given this ammeter. You may be given a different ammeter. I think what is important here is to make sure that when you use this ammeter, you follow the instruction that is given to you. So the lab will tell you for this particular experiment which one to use. Okay, but let's say if you just want to check for your own confirmation, 0 to 200 milliamps will be here. So if you look at this side, all these numbers here are green numbers here are A. Okay, I think it shows pretty clearly on the camera. It's A for ampere, and then the 2 lines is for direct current. So if we want 200 milliampere, you will see where my finger is right now. Is it focusing? This is 200 milliampere, this one here. So I'm going to turn it there. Okay, and this will be 200 milliampere. Okay, so hopefully that's clear. Okay, so this is a digital multimeter. You have to check if it's not working, okay, as stated in the particular best practice video. Okay, follow the playlist, you should be able to find it. Raise your hand, ask for it to be replaced. Okay, sometimes they will give you extra equipment that you don't need to use. For example, a 47 ohm resistor. We don't need a 47 ohm resistor. So this one is not given to you if let's say you are doing this with me in person, because we don't need it. All right. 2 meter rules, each with a millimeter scale. So I got a regular old meter rule here. Cannot really tell. I gotta blur out the background because my room is just too messy and distracting. Okay, so you can see this one is the whole meter rule. Okay, and there is a constant wire attached here. So hopefully you can see there's this wire attached to the meter rule. All right, keep the ruler there. Okay, and then you have 110 cm length of the constant wire. Your crocodile clips, okay, once again, please connect these crocodile clips to the multimeter to check and make sure that the connection inside all of these clamps are okay. How do you know they are okay? Check the best practices video. Give that video more like and views. Or learn something from that. Please check all of this. Make sure the resistance is 0. Okay, what else do we have? I think that's it. We have a switch. And this is the second constantant wire. They call this wire F, that they connect and coil around this block so that you know, we don't have to, you know, play around with it too much and then it spoils. Okay, so let's move on and look at the experiment first. So in this experiment, okay, I'm going to change up the screen a bit so you can see it clearly. So in this experiment, you will investigate how the current in the circuit varies as the resistance of the circuit is changed. So you want to find the relationship between current and resistance of the circuit. What circuit? Later they will draw for you. I'll just write here, I and R. Okay, measure and record the length L of the wire that is labeled F. So in the lab of my college, if you're doing this physically, this particular wire F will be connected to a wooden block. So how you measure this would be actually to count the number of turns. Okay, so you count the number of turns. We have tried to keep it as uniform as possible, and then you make an estimate lah. Okay, either that or the lab assistant would have given you the length. Okay, so this is just a best estimate. Measure the width of this cube and count the number of turns. All right, so if you're confused, let me show you this. Okay, so you can see that this is your wire F. Okay, you can see pretty clearly that there are wires here. All right, and we coil it around this so that it's easy to handle. If let's say you get a pure wire, that is easy to measure. So what I'll suggest that you do is you calculate the number of turns. Okay, so if you are doing a virtual lab, I will record this again for you. You freeze the video, okay, and then you can also measure the dimensions of the cube. Okay, so this is a primary school question. You can measure the dimension of this cube. Okay, measure these dimensions, perimeter, and count the number of turns. Okay, I know it's an estimate, but it should be close to 100 cm. It should be around 100 cm. Okay, hopefully that's clear. Now we move on to the second part of the question. Okay, turn off the wrong camera. Anyway, set up the circuit as shown in figure 1.1. Oh, very simple. Of course, we're going to start you nice and easy first to not scare you. So this is the wire that is attached to the crocodile clip, my meter ruler here. Okay, so later I will show you on the desk cam. Okay, I'm going to connect this to the power supply, a switch, and the ammeter. So what I'll do is I will shrink this diagram and show you on the camera as well. Okay, I've revamped the screen. So it says set up the circuit as shown in figure 1.1. So this is my ruler. Mouse is not part of the experiment, obviously. Okay, so this is my ruler. This is my, I'm not talking about wire F first. So I will first connect to the power supply. So power supply here. Okay, it says that the positive terminal, this positive terminal here, is connected from the left. So I'll try my best to follow the connection as possible. The closer it is, the easier it is for me to spot check my reading. Okay, so I'm going to lay out my wires and I'll connect them. So you can skip this part and only check back later if you want to just be sure that your connection is correct. Okay, please follow the timestamp. So I'll connect it. Positive will be the side that has the nub. If you're not sure, you can open lah. But if you rotate a bit, you will see the, okay, can't see in the camera. You see this side here is positive. Okay, So I'll connect this way. So it'll be like this. I guess like this if you want to. So whenever the current comes out from the positive terminal, current will come out this way, right? So if the current comes out this way, I like to use the red wire. All the connection here that I highlight pink as a reference will be red. So red wire, all the current that is entering the circuit is red. So it's red. Okay. Connect to the switch. And then normally, I mean, this is not very, not super important, but I do this so it's easier for me to check my circuit. Okay. So my main component here would be this ruler. So I'll make sure that I will connect it as the ruler as the main protagonist, the main component. So I'll connect this to the switch. Switch connect to ammeter. Oh, hang on a sec. I know the connection for the ammeter. So current will enter at the red wire. So ammeter got red and black. If you are colorblind and you can't tell red and black, please inform your exam center so that special allocation can be made for you. They may label the wires for you. Alright, so here is my switch. I'm going to connect this to the positive of the ammeter. So normally the ammeter, they would tape the other side that you don't use. Okay, again, watch the video if you want to know more about how to use a multimeter. So the setting is okay, it's already 200 amps. I'm going to leave this here landscape so you can see the reading. So I got the ammeter. The other leg of this ammeter here, this crocodile clip, I will clamp it, this crocodile clip, I will clamp it to the wire. Okay. Where's the wire? Okay, a note about the wire. This wire looks like this. If you look at the camera, it looks like this. There's this thing here pointing out. You will clip it as close to this as possible. Okay, so i.e., your crocodile clip should be very close. Why? Because we don't want extra length. We are going to use this meter rule to measure the length of the wire. I'm pretty sure about it. So the closer, so if you connect here, then you have this extra length, then your result not so good. So I'm going to try my best to connect, making sure that the connection is tight. Of course, you might be wondering, Miss, how to make sure the connection is tight? Yeah, sorry, one woman show, so expect technical errors. So you got to make sure that the clip is clipped on tightly to the wire. This may need a bit of adjustment, especially if your clip is a little bit out of alignment like mine. Okay, so this one I do in real time There's no edit, nothing. Okay I think this is good enough. So you can see it's very close and right at the edge of the connection. Okay, so I'm going to connect this to the wire. And then on the other side of the wire, okay, I know you can't see my wire, so I'm going to move my things a bit. But this is the wire. Okay, so on the other side of the wire, I will connect back to the power supply. And because the current is going out, this one will be black. So I'm going to put this one as a beautiful black and pray we have reading. So depending on your connection, you may or may not have place, or this wire may or may not be long enough to reach the other end. If it's not long enough, please do the reasonable thing and take another connecting wire for that, okay? Don't just try to stretch and then spoil your wires. But mine is still okay, not that bad. So I'll connect this here. Making sure this one is tight, not loose and not sliding around. This one here should be tight and as close to the tape end as possible. So both would be okay. Alright, so I'm going to make sure that this is tight. A way to know that it is tight is that this reading, okay, it will probably never be constant because 200 milliampere is a very sensitive setting, but it should be more or less a constant number. So it will be around 13.1, 13.2. As long as it stays around 13, I'm happy. If it goes from like 13 to 8 to 22 to 47 to 8, okay then something is wrong. Please check your connection because if you see when I fiddle with the connection, this one will change. Okay, so I'm just touching the wires. I'm touching the wires and you can see that the reading will drop. This 12.3 will begin to drop. The other reason why this reading will drop is because, okay, you can see when I move the wire around, this one will drop. So there are many reasons to that. One thing is because as current flows longer in the wire will get hot. And the wire get hot, then the resistance will change. Resistance will increase what? Remember? You probably studied the theory of circuits before. The hotter the conductor, the greater the resistance. The greater the resistance, the smaller the current. So you can see the current has dropped. So when you do this experiment, the faster you do, the better your trend. If you feel that your trend is not nice already, maybe you take 3 reading, turn off the circuit, wait for a circuit to cool down, and then start again. Means the wire not hot one, you cannot detect the difference, but the wire can. You can see this one is already dropping. It was 13, now it's 11.5. The longer I wait, okay, the worse it will be. Second thing about circuit is if you want a good reading, if let's say this is where you start 11.5, you stay at 11.5 for a long time. Don't change already lower. If not, then your graph will be a straight line, and then when you connect, disconnect again, go like that. Okay, so if can, take 6 reading, 1 go. Okay, let us continue. I have done this part of the circuit connection. So attach wire F to the wire, okay, let's see. Attach wire F on the meter rule as shown in figure 1.2. So I'm going to put wire F that looks nothing like this diagram, but again, so that the wire F can last generations of students, we have wound it on a wooden block. Okay, so we're going to connect wire F here. So if you look at the circuit, this is wire F. Okay, the distance X between the crocodile clips should be approximately 50 cm. Okay, so what this does when I introduce F there is that I am, wait, do you need to take the voltmeter reading? No need. Okay, so when I connect the wire F here, what this does is that now it changes the resistance. Previously, it was just the resistance of the wire like this. Now, when you have wire F in between, like this, it splits up the resistance of the main wire. Your wire F is here, like this, lor. And depending on the value of X, it will affect the value of the resistance of the center resistor. So you are varying the resistance, which is what the question wants. So they want it to be approximately 50 cm. And as you can see, with time, this is still dropping because the resistance is increasing. Well, I'm just going to follow first and see what happens. Where is, oh, there is my wire F. Okay, to make sure that it fits in the camera, so that you can see what on earth is happening, I'm going to have to rearrange the table first. So just give me a second. Just going to put this here so you can see. Why am I singing? It's late at night. Okay, I'm going to bloop the voltmeter or the ammeter there. Okay. Right beside my face. Make sure I don't block it. Okay, so we're going to put the wire F here. So I got 2 more wires at my disposal. Stop dropping. Okay, and then I will connect this to here. I mean, I trust that this wire is connected to the nail. Okay, now connect this to here. Alright. This is a standalone freelancer. You don't care about the color also, never mind. They say around 50. So maybe I put 25 to 75 lah, okay? So you just gotta really trust me that is 25 to 75 because I can't zoom in. I guess I can. So hang on, let me click first and then I'll zoom in for you. So connect this to 25. And this part to 75. So it's approximately 50. Does it need to be exactly 50? Nope, it does not. But what you need to do is actually to make sure it's very tight. So there's no sliding around. Because the crocodile, sometimes the teeth will look like this. They don't align. You know, if they don't align, what I do is I use a different wire. Why trouble myself, you know? Walao, this one also the same. Sadness. When life give you bad crocodile clams, what do you do? Okay, hang on. Anyway, just gonna put it around 75, hoping that the clams will be able to clamp tightly. Again, doing this in real time. Okay, so this is pretty good. Okay, so I have clamp. Okay, the battery is here. I'm just gonna put it here. Okay, so I didn't change anything in the circuit. Battery is still here. Switch is still here. Everything is still connected. I just push it out a bit. Tell you what, let me let you see this. Bloop, bloop. Hang on. Boomer. There we go. Boomer doing work. Battery is here. Okay. Switch. And the, whoops, there we go. Oh, when this is here, it actually becomes brighter. Okay, I'm going to keep that there. Remember, we're taking the meter reading right beside my head. All right. So this is my wire F. I keep this here so we can actually see where I'm clamping the wire. I am hoping that if you view this on a big screen, you can see that I put here 25. Well, specifically it's 25.2 lah. And here to be 75. So I click this way. Okay. So that is what you do. Pretty straightforward because it's a pretty straightforward lab. Okay. So now what we're going to do is we are going to take the reading for X, the separation between the two crocodile clams. Okay, so as mentioned just now, my reading was 25.2 and the other side was 75. So I'll write here that X is 75.0 minus 25.2. This will be equal to 49.8 cm. So they say approximately, so roughly lah. But very important, and this is the last time I will remind you, if let's say you are doing the 8 laps with me, this one must be how many decimal point? Follow the sensitivity of the meter ruler is 1 dp. Okay? Make sure you don't lose mark here. Alright, let's continue. Close the switch. Hiya, I closed already. Okay, fine, I open. Open. Okay, I have opened the switch. I have opened the switch. Okay, so the voltmeter reading beside my head is 0. Record the ammeter reading I. So now I'm going to, oh wait, you can't see. Record the ammeter reading I. So I will close the switch and record. I mean, just now it was still around 10.3, 10.4, right? But never mind, let's do it again. Okay, so I'm going to close the switch and this is the first reading. So it will not be stable. It will keep dropping. Choose a number that you like. I think I like 12. Easy to press calculator. Miss, does it really matter? No. As long as it's not too outlandish. Okay? They accept a range one. Or you could wait until it stables. I don't know. The longer that you wait, the more it will drop. Because the wire will get hot. So what do you think? 11? Okay, we'll stick with 11. We need to do the experiment fast. Bro. Milliampere. Because the setting was MA. Okay, so whenever you see this meter, right? Okay, let me show you up close again. Good God, it's dropping fast. You see it's 200 M here. 200 M. M here is for milli. So whatever reading here, 10.8, it will be milli. Okay, so take whichever you think is reasonable and then open again. Take 11, take 10.7, doesn't matter. Okay, open the switch. Next one. What shall we do? We will now change X and repeat C part 2 and D. Okay, what was C part 2 again? C part 2 is to measure and record X. So basically what you're changing is the value of x, which is the distance between this clip and this clip. The black clip where my finger is here and the red clip here. We are changing the length of these two clips. Okay? And record the readings of I. Include values of x squared over x plus L and 1 over I on your table. So we want 6 set of distance x. Okay? I'll just give you a gentle reminder. Think of the range. Largest value of x is 100. We need at least 80 or even better 90% of this range. But it also cannot be 90, 91, 92, 93, 94, 95, 96. Okay, 6 reading. Don't lah. Range means you should have the smaller possible value, maybe 10 or 15, and then going all the way to 90. All right. The intervals are not the same, never mind, as long as you got 6 reading covering a large range. So we have 6 reading of x, and then we read the ammeter reading, and then include the value of x squared over x plus L and 1 over I in your table. Okay, so once you have done that, we will plot the graph of 1 over I on the y-axis and x squared over x plus L on the x-axis. You know the good practices of graphs, so I'll leave it to you. Ooh, more graphs, leave that to you. And once again, find the value of P to Q. So perform the analysis. All right, so you can see there's a repeating pattern. So that's it with question 1 and the circuit. Please make sure you check every single component. I trust that you can do this final part pretty well. Make sure you don't repeat mistakes that you've done. Things like unit, decimal point, and significant figures are very important in question 1. All right, that's all. Have fun with your very first circuit for the semester. Take care, and I'll see you in the lab or the virtual data collection video. Bye-bye.